Hey everybody, welcome to the Smash News Network, least busted name in news. No, I'm not sleeping with any interns if you're wondering. Let's move on to the total electron content forecast to show massive GPS errors and huge chaos happening here in the Earth's plasmasphere and or inner Van Allen belt. So we're going to let this play through a second time here. Shout out once again to Tamitha Scove for forecasting nighttime GPS errors. Huge chaos happening here. See those red blobs happening at nighttime. Most GPS errors happen around the equator at noontime. And we've got things lighting up on our daily space weather videos with huge anomalies happening. It's a result of a coronal mass ejection and a coronal hole wind stream showing up at the same time. So what we were showing you there is the area between your GPS satellite and your handset. A lot of free electrons in a lot of anomalous locations. We do see some significant charging hazards here as well. Surface charging happening around the Central Pacific at the moment. Could cause some communications errors. Here is your total electron content. This is your relativistic electrons rather for the past year. That's reported by solon.info/solar. And there is the past 3 days of electron flux. Next, we're going to show you the ionosphere. First, the forecast. And we're looking for continued levels here. Fairly level electron flux is the NOAA forecast. No arguments there. Next, the ionosphere. Let's see if we see any anomalies in the ionosphere. We're going to show you the F layer located here at about 300 kilometers of altitude. And indeed, some errors, some not errors, some anomalies happening there in the ionosphere. Make sure you watch our previous 2 daily space weather videos. We've got crazy list of volcanoes happening. Consider becoming a member of the Smash team. You get even more disaster reports that way, especially at the gold and silver levels. Thanks to the Smash team for making these videos more likely to exist and remain publicly visible. We're going to stop this at the latest image here, and then we're going to show you the anomalygram. There's the latest image. That's 12:45 Universal Time. Here's the anomalygram showing anomaly in megahertz from the 30-day median. So some significant high-frequency anomalies here, both north and south of the equator. Some significant swings in the ionospheric vibrational frequency over the central African continent. We've been documenting that for a couple of weeks on the channel. And if you're a new viewer, thanks for tuning in. Congratulations on realizing we exist. Anyway, there's the latest image, 12:45 Universal Time ionogram, 12:45 Universal Time anomalygram. And high-frequency anomalies happening here over places like Papua New Guinea, Oceania, Southeast Asia, etc. Anyway, welcome to the DR Renaissance. Visit our links at smashamash.com. You can find all kinds of interesting stuff going on there. Once again, thanks to the Smash team, the true source of funding for the content. Smashamash.com/Smash team. Join at the gold or silver level. There are also posts for those of you unwilling to open your cobweb-encrusted wallets and send us a few dollars per month. Next thing is the bonus features ground-based solar observatory. And this one's located at El Teide, Spain. You can see a CME happening here from Sunspot 2936. A great brightening right there in the middle of the umbra. Some limited imagery, but interesting nonetheless. So next, your intensitygram and colorized magnetogram. We press refresh so you can see that they are the freshest. 2936 still large and in charge, still capable of producing major flares. That's bigger than the Earth, that umbra. Over here we've got 2940. Still quite huge. Quite a lot of umbrae. And there's 2941, the newest sunspot on the Earth-facing portion of the disk. 2939 is largely stable over the past 24 hours. Here are the fields. There's 2939. There's 2941. There's 2940. And I think it might be the most significant sunspot of solar cycle 25 so far, Sunspot 2936. It's monstrous. It's becoming more likely to produce major flares as it approaches the limb. So here you can see a coronal mass ejection happening here, a great prominence showing up there associated with that Sunspot 2936. The NASA GOES SUVI, the NASA GOES 16 SUVI is fantastic at showing prominences with its wide angle. A little wider angle and a little lower resolution than the SDO. And for that, we thank everybody for having access to both. So we're going to close things out with some full disk views here of the closest star. Thanks for tuning in once again, stargazers. This is ionized helium, just like the last frames. And here's some ionized iron, 171 angstroms. Our in-house favorite here at smashamash.com. We out. May that solar wind be at your back.